Hello, Mr. Gigabytes here, and today we're going to be putting in a mini ITX mainboard into the beige retro keyboard case. Now there will be a couple of firsts, I should say. Number one, we're going to be using the Pico ITX power supply. We're going to be using the non-light up keyboard. And we're also going to be using slightly taller standoffs in the case than what we have before. Now, full disclosure, I've already done this one other time. And I fully assembled the case and got it powered up and was ready to do the video. But we had some problems with recording, and it ended up being the entire thing was we just ended up not being able to use any of the recording. The other new thing is you'll notice that we have an overhead shot of the build. That should help with so that you can see exactly what I'm doing without having a long side shot like we had in previous videos. So, with that in mind, we're going to go ahead and get started. And first thing I'm going to do is we're going to pull the keyboard plate off. We'll set that aside for now. Now, I've pre-done, as I said, I've already done this once in its entirety. So I've already fastened 3 of the standoffs, and I've already pre-threaded 3 screws on the back that I'll show you in a minute. One of the design changes for this case that I've done is we put a panel on here that looks very reminiscent of a VIC-20 or C16, C64 panel. That will have room for ports and room for the power switch. And I've removed the power switch because on this particular build, I'm going to be using a square power button, but unfortunately it's a lot longer than the round power buttons that I've used, and so it sort of interferes with this particular screw hole right here. It actually goes over the motherboard. In the final designs, this panel is actually lower, and this entire assembly is moved over about 1 centimeter, so there will be room for different types of buttons, and there'll be more room in this case on this side for things to go into this panel. Right now, obviously, there's not a lot of room, but something we've fixed in the final design. Again, I've mentioned this before in other videos. These are prototypes, so just keep that in mind while we're putting together. The instructions are going to essentially be the same, with very, very little differentiation. So I'm going to go ahead. I'm going to thread this final standoff in place, and what I'm going to use is to help get it started and to give me a little more leverage is a 6mm socket, and all this is a little socket adapter. It makes it a little nicer to grip. So when I'm putting it into, especially working in under here, it helps me to get in and get that threaded down. Now, I should mention another change. This is also mentioned in another video, that this top piece will actually be removable on the final design. I mentioned in a previous video that we needed to glue this down to give this some structure. We figured out a way that we can actually screw it down. So there's actually 5 screws will hold this whole plate in. 1 here, and then there'll be 3 along the back, here, here, and here. and it will give the piece enough structure that we don't have to worry about. We really don't have to worry about it too much. And then, in addition to this piece coming off, the backplate will also be removable. So you can actually, this whole plate will come off, so that we can custom manufacture different styles of backplates, including one for a Commodore 64, Commodore VIC-20, and a C16 board as well. So those are coming. I just recently acquired a Commodore and a VIC-20, Commodore 64 and a VIC-20. So those will, we're going to measure those out. We're going to design a custom backplate, so you can take your old main boards, or maybe even a Commodore 64 Mark II board, and mount them into this case. And we'll also have we'll also be able to custom manufacture a keyboard plate to fit the Commodore keyboard and mount it up in here, so that you can actually have the Commodore keyboard and the Commodore mainboard mounted into this case. So I believe that's it for for all the design changes. So we're going to just go ahead and let's get our tray of parts here. And again, this is a 7mm standoff, and I'm using nylon standoffs. We will most likely use nylon standoffs in the final product, but we will use metal screws. And the nylon standoffs with the PVC actually grip the case really well. The nylon and the PVC actually work very, very well together. So well that this will definitely wear your fingers out. Even after this has been removed a couple of times, it's still very, very it's very tight in there. It threads very well with this case. So there's the motherboard standoffs done. And what we'll do next is we're going to take this hard drive, and I'm going to use this. I've used on my other keyboard case, on my black one, I've actually used a solid state. But on this one, we're going to use a standard hard drive with Windows 10 on it. Though I will most likely, I believe this is from one of my laptops, in fact. And in our trial run, this actually did start to boot Windows 10, and then I just shut it down. I'm not terribly interested in Windows 10. I run Linux, specifically Gigastrand OS, or either FreeSpire or Linspire. Gigastrand OS is an Ubuntu, or Gigastrand OS is actually Debian based. Ubuntu, or the Linspire and FreeSpire are both Ubuntu based. So we're going to just kind of put these. So we threaded these longer standoffs in, and there will actually be 8 standoffs that come with the final product. The other 4 standoffs won't be as long as this. They'll be these 7mm standoffs. But you can do the same thing with the 7mm standoffs. And what this does is it gives it a little bit of height to stand off the bottom of the case because of this circuit board. And it's actually nice to give it a little height. And I need the height for the type of cable I'm going to use, and I'll show you that here in a little bit. So we're just going to hold this in place. We've got it over the posts here. Going to hold this in place, and we'll just tighten this down. Now these are nylon screws, and they work just fine for this. But of course, the final product will actually have metal, standard metal screws. I like working with the metal screws a lot better, to be honest with you, but these are okay. They're just okay. So here we go, all 4 of those screws tighten down here. Now you'll see these other holes here. These are actually for 5 1/4, for 3.5 inch hard drive. So you can mount a 3.5 inch hard drive on the case as well. Not at the same time, obviously. It occupies the same space. But yeah, you can have a 3.5 or 2.5 inch hard drive. We're going to use a 2.5 inch because that's what I happen to have here. So, all right, so we're going to go ahead and put the back plate in. Now, the nature of this case, it doesn't always like to grab the spring plate in this. And especially after you've done this a couple of different times, like I have, but you'll find it'll hold it just fine. So we're going to put this in. And I can hear some of you saying, well, don't grab the processor by the heatsink. Well, on this board, it doesn't seem to mind all that much. So, there we go. Holes are lining up, so we're going to start. And again, I'm going to use nylon screws. Of course, like I said, there will be metal screws that come in the final product. They're a lot easier to work with. Number one, they respond to a magnetic screwdriver. And this happens to be a magnetic screwdriver, but magnetism is ineffectual against nylon. Go figure, huh? I usually do a kind of a star pattern, but the prototype case, because I can't remove this part, this is actually glued in on the prototype. I'm going to do the back two first, and that actually helps align the front 2 screws. And what I'm going to do to help me get in under there, we're just going to use this little 2-inch, or this little 3-inch bit, and we'll get the screw in place. And I'm just going to hold it with one finger to apply a little bit of pressure, and then I just spin it with the other 2 fingers. As long as you've got all the holes lined up and everything, and you don't have it cross-threaded, you really shouldn't have any issues threading it through. And this bit's a little bit chewed up. It helps hold the screw on. That always helps. At least it helps with these nylon screws anyway. like that. Okay, so we've got those screws in. I'm going to go ahead and mount the speaker, which goes right here on this board. Then I'm going to thread in the power switch. Now this power switch I have not soldered the connections on this. But because it's just a demonstration here, I think we'll be fine. I twisted the wires up and so they won't move, but of course you're gonna get something a lot better on the final product. Just thread the nut on like that. This happens to be a round base. It's a square button, but it's a round base. And it stays, if you can see that, it's up off the board and not interfering with anything, so. This side plate too is actually removable. It's just held in with 2 screws. And this actually says reset switch, but it's the power switch. So put that in there, and we'll run the LED over to the same header. At this point, it's just essentially like building a computer. There really isn't much to it. I mean, this is a computer case after all. Positive to positive, negative to negative. It's not terribly hard. Just about anything nowadays is keyed for the right direction. This particular motherboard is an A6N2100. It's a BioStar, and they're they're a manufacturer that I really like, but also am sometimes kind of leery of because they like to do things a little cheaply. But I've had really good luck with them, honestly. They've been a really good board. But this is just a dual core AMD E2100, so it's kind of a lower end processor. On one of my other computers, and I might have a video on that later on. I've got a quad core A10, and the motherboard that they use is almost identical to this board. They just upgraded the processor in it, which is fine by me. So, that's what this board really lacked, was a better processor. But a dual core will definitely get the job done for what I'm going to use it for. So I'm using this header, this extension cable, and the reason I'm doing that is because the power connector for the Pico ITX is actually too tall, so that when I set the keyboard tray on it, it would actually prop the keyboard tray up. So I'm using this extension, and this one's a rather nice extension. And we're going to use it to plug into the Pico ITX power supply here. So, and I'm just going to Just kind of set it like that. I'm not going to worry too much about where the cables are going right this second, because this is a demonstration model, so this isn't going out to anybody anyway. It's just going to be my machine. Eventually, I would like to take this and get it all nice and strapped down with some zip ties, or get it all run like really nicely. But for now, this will work. All right, so motherboard's in place. We have to connect the 12-volt pin header, and this is required for this motherboard, even though it is just a little dual-core AMD unit. We're going to plug it in right there. Just going to make sure these cables aren't in the way of anything else. Now, ideally, you want to run these around the front if you can, because if you put a fan in here, and I'm sure you would want to put a fan back here that it's actually cut out for it, and you can put an 80mm fan in there, but if you put an 80mm fan in there, of course, you wouldn't want all those cables in the way. So ideally, you would run them around the front of the case. But I'm not putting in a fan. This is an air-cooled processor, and don't really need a fan for this particular unit. All right, so let's put the keyboard tray on. And I'm going to put the keyboard tray on without the keyboard in it, just to make sure everything fits. Now, we'll just put the screw in. And I like using, I've got power tools to do this, but I really like using hand tools because you don't want to over-tighten anything in this case. It would be easy with power tools to strip out any of the threads on this case. So we're going to go ahead and do the other side here. There we go. So that's good. Now, what I'm going to do is I'm going to plug in the keyboard, and unfortunately, for some reason, I do not have one of these an extra one of these adapters, and I just literally right now stole it out of my my main computer. And if you watch the video, where I take you on a tour of the office, you'll see that computer kind of in action. So I'm going to plug that into the USB header, any one of them, it doesn't really matter. I am also going to take this and we'll plug this into serial ATA1. And I've got a right angle connector on this. And if you had the hard drive screwed directly into the board, that might be a problem. But that is why I use this. That's part of the reason why I use the standoffs. So that I can plug this in, standing far enough off the board that I can just plug that cable in like that. route it this way a little bit. Now, we'll plug our keyboard in. I'm going to point something out about this keyboard real quick. You probably can see on the camera that some of the keys are a little whiter than, have a little lighter lettering than the others. And that's because I actually applied, I was kind of hoping to show you how to apply all these, but this has got a Commodore sticker set that relabels the keys with pet ski. And I've got the black, white, red, reverse on, reverse off. And as I was applying these, I was double checking them with Vice, and I used positional keyboard mapping, because positional keyboard mapping actually gives you a few other abilities than the symbolic mapping. So a key in this position is this key, and a key in this position is this key, and so on and so forth. You can actually you actually are able to generate a few more characters, which I do need while I'm writing programs. And that's what I intend to do with this, is to write some programs. So, because this is a Pico ITX, it plugs in with a power brick. And this one is not the power brick that'll come with it. You'll actually get one that's specifically that's got all the right voltages and everything. This is my universal one, and it does 12 volts, and you need 12 volts and about anywhere from 5 to 8 amps in order to power this. And this is actually a 10 amp power supply, so we're given a little extra juice to play with. So I'm going to go ahead and plug it in here. We'll plug it into the power. We'll get our lights to come on. That's why this square monitor is out. We're going to use this monitor here to hook up to it. Just a little touch of nostalgia there. And then I'm going to use one of my bench mice. We'll just plug a USB mouse into the back here. You sure it's definitely plugged in? Yes, I'm definitely sure it's plugged in. Okay. So, now we just hit this side button, turn it on. We've got a nice bright LED light, and there's our BioStar BIOS screen. Caps lock light works, so we have power to the keyboard. But so that's how you build a mini ITX board into one of these cases. Thank you for watching.